time. Good morning, everyone. I think we're hopefully ready to start the webinar. So like you heard, please mute yourself if you are not muted and keep your camera off, except for the speakers. I may have some connection issues, but hopefully my colleagues can cover. Let me just first share the introduction slides before we start. Okay, can Rebecca confirm that you can see my slides?
Works perfectly.
Yeah, perfect.
Okay, good. So I think we are ready. Good morning, everyone. So my name is Sanna Alaranta and I'm from Lux Innovation in Luxembourg. It's the national innovation agency for Luxembourg, and I'm the national contact point for Cluster 5 and Cluster 2 also in Horizon Europe. And today we are holding a Greenet webinar. So Greenet is the network of Horizon Europe Cluster 5 national contact points. And the topic of today is Earth observation and the Copernicus and Galileo services. And as you know, this is an transversal topic, so that's why we have invited other cluster NCPs to join. So we have more than just Cluster 5 NCPs joining today. And I would like to give the floor to my colleagues, Estonian colleague Maria Hapit, who has helped to put together the agenda, invited the speakers, so that she can briefly introduce the agenda today.
So hello from Estonia. I'm Mari Haavi from Estonian Research Council, a project partner in Greenet, working in close cooperation with Sanna, and in charge of Cluster 5 energy and transport issues. The reason for this event was that in many, actually hundreds of topics, Commission proposes to use Copernicus or Galileo systems. So to help NCPs to be ready to explain to their clients why and how and what is the advantage, we decided to build up this program and share with you theoretical presentations and practical examples. Well, as a proud Estonian, of course, I picked all practical examples from Estonia. So first we have two presentations from European Commission. Copernicus and Horizon Europe Research will be presented by Michael Rixen, the DG for Defense Industry and Space, followed by a presentation on how satellite navigation can enable your projects from Vera Pinto from the same DG. And we will have 3 practical examples from Tartu Observatory of Tartu University by Kersti Kangro, from Agricultural Register and Information by Siim Randver, and from Tallinn Technical University by Liis Sipelgas. Some request from the organizers. You are automatically muted and your camera is off. So to avoid noise and to avoid disruptions, you are kindly asked to write your questions under the, here under the, in this system in Teams, so that we will read them out to the speaker and the speaker will be able to answer. And the slides will be shared and the recordings will be shared to Cluster 5 NCPs because it is an event of our project.
And here to add, sorry, I think we can share them also to the other NCPs that are joining, just to keep them to NCPs and not outside the NCP community.
Yeah. Anyway, it is not a, well, in this sense, it is not a public event. So yeah. Can we now proceed with our program and invite Michael Rixen to start our program of the day, please. And all your questions are highly appreciated.
Good morning, everyone. Thank you very much for the opportunity and the invitation. I hope you can see my slides. Can someone confirm that?
Yes, it's perfect.
Yeah.
Sound
Okay.
and picture both.
Okay, thank you very much for the confirmation, Maria. So it's my pleasure actually to provide you with a small introduction to Copernicus, Earth observations, and how that fits also into the Horizon Europe research landscape, which I think everyone realizes is quite a wide landscape, given all the opportunities that Horizon Europe research offers. And this one here is somewhat focused on cluster 5, but you will see that it's quite vast in terms of opportunities for research and for Earth observations. So I wanted to start with a bit of programmatic context first, and you'll also hear from my colleague in the next presentation as well, but just to set the scene here. So Copernicus is part of the space program. So there are currently existing systems, one of which is the Galileo and EGNOS, so all about navigation. Copernicus is the Earth observation component of the space program. We have also new systems coming up, like the Space Situational Awareness and GovSatCom about communication and IRIS², but I'm not going to dwell into those components. There are also cross-cutting activities part of the space program, such as access to space, in terms of launchers and so forth. All the dimension of industry, governance, space policy and so forth, and also, the kind of growing elements of security as everyone realizes in this global context. There are also associated elements here, one of which is Destination Earth, part of the Digital EU program and DG Connect, which we're also trying to leverage to the extent possible, and the Secure Connectivity program. In terms of EU policies, the space program actually is expected to support a number of them, in particular, natural disturbances, weather-related challenges, monitoring of CO2 and how that supports the Paris Agreement, the agriculture policy of the EU, all the digital agenda, and using all that through also the space and satellites, protection, civil protection and emergency management service, and also all transport and support to aviation, maritime and land transport. Those are the kind of 6 foci area, but there are, as you can imagine, a lot more, and I'm going to provide some examples later on. So Copernicus itself didn't start, recently. I mean, it emerged from a series of R&D programs. It was actually called GMES in the past, Global Monitoring for Environment and Security. So it started basically, 15, 20 years ago with preparatory actions and so forth. And it only became operational for most of the services starting from 2014 on. The latest addition was the Copernicus Climate Change Service, which became operational in 2018. And so that led into now this new space program. And you see also that the funding resourcing has also been increasing over time, supported also by the underlying research, from Framework Program 6, 7, Horizon 2020, and Horizon Europe now. This is also being complemented by some substantial contribution from the European Space Agency, because they're also supporting the R&D development of the what we call the prime satellites, basically. And so this is a critical part of choice for Copernicus. Of course, this is all supported by some legal basis. I'm not going to go into the details, but just for information, there are some relevant text and regulations that are actually ensuring that we have all the baseline here, that we have also all the agreements with different implementing entities, and also this is not set in stone. Things are also evolving in time. A new possible addition will be the EU SatCen Satellite Center, which will also probably take part in a stronger contribution on the security side. But this is also being finalized, not yet fully confirmed. So now just a bit of technical overview for those who are not so familiar with Copernicus. So the baseline of Copernicus as an Earth observation component of the space program are those satellites, the so-called Sentinels. We have a number of them now already flying, and another set of Sentinels currently planned for launch over the coming years. So this is really the backbone of the Copernicus enterprise. Those satellites, Sentinels, are also being complemented by what we call the contributing missions. So we have specific agreements with a number of providers, what we call those space third-party elements. And those satellite data are being used into the various services, the six services currently being operated by Copernicus, covering land, marine, atmosphere, emergency, security, and climate change. And those are expected to deliver added value through different products, applications, and services. Of course, the ground-based data is also quite fundamental in terms of adding value to the service, evaluating the quality of the service, and so forth. Also calibrating satellite data, to name a few of those use of ground-based data. The basic principle of Copernicus is that we provide open and free data policy. There are a few exceptions when it comes to emergency or security, because we don't want to step on the toes of national jurisdictions, and so we have carefully crafted the mandate of the various services. And also, it's important to recall that Copernicus is end-user driven. So we receive requirements from the policy side, from end users, and that's how we shape the services. In terms of implementation, so in terms of the space coordination, this is basically delegated to ESA and EUMETSAT for the operational as well of some of the satellites, and as well, some of the contributing missions. As I said before, we have some specific agreements with third party. The services themselves are implemented by different so-called entrusted entities. You see here a number of them, like the European Centre for Medium-Range Weather Forecasts, Mercator Océan, and so forth. And then for the in-situ part, of course, the member states play a critical role because this is part of their mandate. But when it comes to the services, this is being coordinated by the European Environment Agency. Here on this slide, you see currently the Sentinels that we have currently flying in space, and some which are planned for launch over the coming years. We are currently trying to ensure that we kind of meet the challenges of the scheduling the launch. This is currently a bit of an issue currently because of the global context, and also some of the failure of launches that has happened recently. So together with ESA and partners, we are working hard to find the proper solution to actually launch those satellites as soon as possible, and as soon as they are ready for launch as well. You see that the different Sentinels here are covering the different parts of the Earth system, basically, so that we can use them to support the services, covering land, atmosphere, ocean, and so forth. Again, here, just would like to emphasize here that, Copernicus being driven by user needs is really fundamental. And we actually have engineered a system through the different services to collect those user needs at the policy level, whether it's at the European level, at national level or regional level, but also through the services and through the downstream part of the services. So that we have, let's say, a virtuous cycle of collecting user requirements and then implementing those requirements when they are, validated through the various needs evaluation. So now I'm going to provide you with just a few examples of what the different services are covering. As you can imagine, with those 6 services, we can cover pretty much everything, I would say, you know, from climate change, security, health, blue economy, energy and natural resources, transport, and so forth. And there are also new opportunities emerging, you know, like urban planning or forestry. We realize that there are so many opportunities that were initially not even envisaged with everything that the services and the Sentinel satellites are offering. So, for example, land monitoring, some of the products are covering, you know, land cover or hydrographic and digital elevation maps, percentage of built areas, riparian zones, urban atlases, you know, biodiversity, protected areas like Natural 2000 and so forth. And you see on the left-hand side, you know, some of the you know, societal benefit areas, I would call them, that the land monitoring can cover. Same for marine monitoring. So, and you see here a number of products that the service is providing, like sea level, ocean salinity, temperature, sea ice, and so forth. And those kind of basic physical or biogeochemical data are then used to support some of the services, you know, for support maritime safety, coastal management, climate monitoring, and so forth. Again, same for the atmospheric monitoring, you know, focusing broadly on atmospheric composition and air quality, but it also supports, you know, additional and associated product like, you know, monitoring the ozone layer, monitoring solar radiation, how that can support renewable energy plants, for example, monitoring also the emissions and surface fluxes, because that feeds directly also into some of the systems that we are currently developing to monitor CO2 emissions in support of the Paris Agreement. On the climate change side, and indeed, you know, when you collect so much Earth observations over time, you can start building what we call these climate data records, so that we have a complete history of the climate, and that supports, you know, mitigation and adaptation strategies. Also through, you know, the whole sequence of, you know, timescales in the past, present, and future, with, you know, historical climate projections at the regional or global scale, and also, you know, in the future, how that can support, you know, the IPCC work and, of course, the UNFCCC. Now moving to the emergency management, you know, Earth observations are, of course, you know, they monitor the Earth, you know, on a continuous basis, and that can help supporting, you know, risk and recovery mapping, you know, with on the spot requests for Earth observations, and then downstream products, you know, such as early warnings for floods, forest fires, and droughts in particular. Also supporting humanitarian crisis, because we can have specific requests for data acquisition in crisis areas that we can monitor. Last but not least, the security part, that's also being implemented by a set of entrusted entities covering border surveillance, maritime surveillance, and also support to EU external action. And, you know, that can range from, you know, coastal monitoring, border monitoring, maritime surveillance, you know, vessel detection or oil spill detection, and those kind of things. Now a bit moving to research. You know, research is really fundamental to ensure that the system remains, you know, state of the art, you know, cutting edge, and leverages the latest research and development, you know, at national level and European level, you know, so all the developments from the academic area and so forth. We have tried to organize this Copernicus evolution in 4 dimensions, one of which is to evolve, of course, the space component, try also to enhance the performance, reduce dependencies, and so forth. Building also a bit of a hybrid constellation, not just big satellites, but also small satellites, and this is, you know, growing into the picture. Uplifting the service is quite important, and you know, because of all the developments on the digital landscape with the AI, high performance computing, and so forth, we are trying to leverage all these new tools to really ensure that, you know, our services are becoming more and more efficient and accurate. You see also probably that there's a growing number of data infrastructure, and we're trying to integrate them or at least interface them so that data become discoverable and usable from various places. Last but not least, also important to bring the computing power to the data, because the amount of data is so huge these days that you cannot move data around so easily now. Last but not least, also fostering the Copernicus downstream element is really important. Anticipate the user needs, but also really promoting the use on the use of Copernicus data on the downstream part of it. That evolution has been planned for every single what we call multi-annual financial framework. So currently we have a roadmap for 21-27, and that has been planned and developed with the EU member states, and I'm sure some of the attendees have been contributing to this roadmap as well. So as part of that roadmap, expanding the sentinels is quite important. And you see here a number of those who are currently planned and being developed in collaboration with ESA. Of course, these new satellites will also have tremendous opportunities for the services to use them, and also to the downstream part of Copernicus to really leverage those new data. Also, more maybe on the longer term, and it's also maybe part of something you might consider, in this, whether you are involved in those some of those upcoming calls. Think maybe what could be next step in what the space component could look like in the future. Could be as of today, high quality sentinels, but also maybe with a mix in the future with small satellites, or maybe small satellites and drones and so forth. So it's also good to have that in mind, on the medium to long term. I'm going to skip this slide. So now, how is this and whole research being organized? We kind of segment this in 3 or 4 tiers. One is the tier 1 is really to a time scale of a few months. So we work directly within each one of those services at the operational level. So this is funded in-house through Copernicus. Somewhat similar as tier 2, but a little bit more longer time scale, 1 to 2 years. So it's really to prepare and test the evolution of the services. And this one is typically outsourced to the research community, but yet funded through Copernicus. The tier 3, which is the one that is probably of most interest to the attendees of this call today, is this medium to long-term upgrades of the service, typically funded by Horizon Europe calls. And we have this set of what we call Copernicus evolution calls, and I'm going to provide a bit more details on that. And the tier 4 is those longer-term and broader upgrades and uptake of Earth observation and Copernicus data across Horizon Europe and National Research Program. And that also is a place where you would find calls typically in cluster 5, for example. I'm going to also address that in a minute. So if you're not familiar with the Horizon Europe, and I'm still also learning my way into this, so it's organized across 3 pillars. So you see probably some of the elements that you are familiar with, like the Marie Curie Fellowship, research infrastructure under Pillar 1. Under Pillar 2, this is where you find those clusters 1, 2, 3, 4, 5, 6. Cluster 4 is the one on digital industry and space, which is really targeted to, partially at least, to the Copernicus evolution. But you have also those cluster 5 and 6, cluster 5 on climate and so forth, and cluster 6 on food agriculture and so forth. The Copernicus evolution itself is targeted under cluster 4. And so here you see the 4 destination, sorry, the 6 destination on the cluster 4. Destination 5 is the one hosting actually the Copernicus evolution. And so in terms of roadmap, under those Copernicus evolution calls, under cluster 4, destination 5, has been planned, roughly speaking, across the different services, atmosphere, climate change, CO2, marine, land monitoring, and so forth. And you see here in green, all those topics that have already been part of previous calls, either in 21, 22, or in 23-24, and you see also the other associated budgets. The remaining calls are those that are still to be implemented in 25-27 period, and for which we are waiting, the corresponding budget and then the implementation phase into the corresponding calls. As I think Maria recalled earlier in the call, there are a lot of places within Horizon Europe work programs where we have this very explicit request, or at least promotion or encouragement to use Copernicus and Galileo data. So it goes to say actually that there are so many opportunities, and not just under our Copernicus evolution calls under cluster 4, but also cluster 5, cluster 6, and many other areas in Horizon Europe where the use of Copernicus can actually boost your project and boost of course the uptake of Copernicus, which is obviously an important target for the Commission to promote and ensure that there is a full leverage of the investment made by the Commission to actually ensure that downstream exploitation in terms of market development, job creation, and so forth, to ensure that we tap into the entire benefit of Copernicus. So this is fundamentally the prime reason why you see this kind of text in the work program of Horizon Europe when it's relevant, of course. And with that, I think I'm done, and thank you very much for your attention, and I'm ready to take any questions if there are some.
Thanks
Over
a
to you,
lot.
Mary.
Thanks a lot. That was really great. Unfortunately, I couldn't see the slides, but I'm sure I'm the only one. So everyone, if you have any questions, on this presentation, please write them in the chat now. I had some questions that were sent beforehand during the registration survey. So I will start with those. Actually, there were at least 2 questions really dealing with the practical side of how, in practical terms, to include and get the access and be in contact with Copernicus and Galileo for the proposals that go into cluster 5 or cluster 6. Do you have any advice on that?
Yeah, well, I mean, I can think of at least a number of ways. When it comes to, being encouraged to use Earth observation, in particular Copernicus data, all the services have their, data store basically. So when you go to the, any one of those services, you have entries to the data, products, applications, and so forth. So this is, the practical way you would do it. The same goes for Sentinel data directly, and very recently, Copernicus has implemented a data access which is specific to all the Sentinel data, which is currently being implemented to really bring the different Sentinel data portals together through a single entry point, basically. So that's for the data part. Of course, when developing a proposal, it's also fundamental to reach out to users, or ways you can actually exploit the data. And so I believe, if I remember correctly, under the Horizon Europe portal, you have also ways to approach different participants, prospective participants in the course that can help you, for example, develop use cases or those kind of things. So this is also quite important. Last but not least, getting in touch directly with some of the entrusted entities could also be a very practical way to identify those areas where Copernicus data are to be used critically, in terms of, fundamental, whether that's policy data users, at national level or European level. I mean, there are some elements which are worth exploring in terms of, areas of high relevance, in terms of policy, whether that's a European level or national policy level. So the Copernicus entrusted entities are usually very open to see their products being exploited. So it's I think a good advice to get in touch with them directly.
Thank you. Yeah, thanks a lot. That was a very covering answer, I think. I have another question here in the chat. So is the data free for researchers? Are there any Copernicus services that are not free of charge?
Yeah, good question. I mean, in general, as a general principle, the Copernicus data policy is free and open, but with some caveats because that policy has been designed so as not to step on the toes of the national mandates. When it comes to emergency or security, it's a bit more delicate, of course, because at national level, countries have their own, of course, jurisdictions. When it comes to, for example, send an alert signal for flood alert or fire alert, whatever. So they have their national mandate and authority to do that, which Copernicus doesn't have necessarily unless it's engineered as part of the system. So that's basically the only restriction, and the same goes for the security part, which is also somewhat for obvious reasons. EU member states have their own ways of dealing with the security matters, of course, but the security service of Copernicus is there to support them as well, and as part of those services, the specific protocols have been engineered to access data and eventually trigger a specific response from those services.
Okay, good. Thanks a lot. I actually had another question that was sent beforehand. I don't know if it's very wide, but how does the Copernicus compare with other satellite systems?
Copernicus itself is not just about satellites. Just to be clear, it's of course leveraging the Sentinel satellites as well as the Copernicus contributing missions. So as part of the contributing missions, with whom we have some arrangements, some agreements, some partnerships, they are in a way fully part of the Copernicus pipeline, so to speak, right? Now there are also other satellites with whom we don't have any agreement or which Copernicus doesn't exploit for whatever reason, because there is no identified user requirements, or because there is no immediate need for for specific products because Europe does it on its own. So it all depends, right? It's all, as I said, it's all driven by user requirements. The fundamentals, or let's say the backbone, is really Sentinels, because that's the kind of, let's say, common denominator in terms of where the Earth observations needs to support the services. That was really the backbone, and then that has been supplemented or complemented by the contributing missions, where specific needs were identified that had to be filled with additional satellite missions or specific data products that we would either deem that would not necessarily justify the launch of a new Sentinel mission, and that would be implemented in more cost-effective way just through an agreement with the Copernicus contributing missions.
Thanks a lot. I think there are no more questions coming in. I would like to thank you very much. I think that was very useful. I don't know if you're able to stay a bit longer, but I would like.
I can.
Yes, great. So in case we have questions a bit later on, now I would like to give
Sanna,
the floor.
there is one more question just came in.
Yes. Okay, I think we are running a bit late.
We will manage.
So entities that ask for the Copernicus data, have they got to rationalize their demand? What sort of information is necessary? So
Yeah, I see the question in the chat now. I'm not sure I understand fully in terms of asking for Copernicus data. Copernicus data are available, right? I mean, on the different portals of the respective repositories of the different services, so people can grab them. Now, if this relates to new requirements, then I mean there are different ways you can do that. You can do that through direct contacts with the different services. They have their own way of collecting user requirements. Another way to do it is eventually to get in touch with your national contact points. I mean, there are representatives on what we call our user forums. So every country, member state have representatives, and they can convey different user requirements to the Copernicus, to the Commission, basically, to us. And so that's another way to provide user requirements. I'm not sure I understand the question, but at least I provided two angles. Hopefully that answered the question.
Thank you. And then there was, I think, a rather quick question. The costs of using Copernicus are eligible in the EU projects.
I'm not sure. I mean, the cost of using, again, it's free of charge, right? So you can just download the data. So there wouldn't be any cost associated with that. Now, if you mean, you need a computer to to download the data and process the data on your own, probably, but it's always best to check, right? Because as part of each call, you have your specific annexes which provide detail on what are your corresponding eligible costs, and that can sometimes vary from one Horizon Europe call to another. I mean, it would be difficult to tell, in a specific case, whether that's the case for all or not of the calls.
Thank you. And I have a confirmation from the previous on the previous question that it was covering, your answer was covering the question.
Okay.
I think now, thanks a lot. I think now we have to move on. So I would like to ask Vera Pinto, thanks for joining. And do you have slides to share?
Yes, good morning, everyone, and thank you for giving me this opportunity to speak about Galileo. That was actually the project that brought me to Europe to work on. I hope that you are seeing my slides.
Can somebody confirm? On my side, I have issues, but maybe my colleagues can confirm that the slides are visible.
Everything is perfect. Slides and sound, everything.
Super, great. Thank you so much. So Galileo is the EU global navigation satellite system. Is usually, we tend in our daily lives to say, let me turn to GPS, but actually what we are doing is turning on a global navigation satellite system receiver. And Galileo, like I say, is the EU global navigation satellite system. And by global, it means that it provides service all over the world. So anyone with a receiver that is Galileo enabled can have access to the signals. And is also the only civilian system. So the Galileo is run by the European Union, is like some of the Copernicus infrastructure owned by the European Union, and is run the only system that is civilian. So Michel already gave a bit of a review of the EU space program. So since 2021, that all the components of the EU space program came together into one single regulation. And what you see here is a bit what Michel also show you about the overview of the EU space program. So Galileo is the global navigation system, but we also have a regional system that is called EGNOS. And basically, just to give you a brief description on what is this regional system, this is what we call augmentation system. So EGNOS works on top of the other global navigation satellite systems to improve its reliability, its security, its precision. Okay, so it's mainly used for critical services, like, for example, airports and landing in the airport, to make sure that everything goes okay. There's multiple regional services all over the world. So EGNOS is the one all over Europe. You have WAS in US. You also have Japan, India. They also have their own. And EGNOS also works with Galileo. So global satellite navigation, actually, represents around 10% of the EU GDP. So the gross domestic product of the European Union economy. It means that around 10% of the gross domestic product is enabled directly by satellite navigation. I will explain you a bit more about all the different areas where Galileo works, but I would just like to highlight that satellite navigation, so meaning providing the service of navigation, positioning, and timing, it actually has a huge impact and on the European Union economy, and most people are not even aware of this. We always think about satellite navigation of going from point A to point B and the best way to achieve there. But indeed, there's a lot of areas of applications where this type of services are used, and it generates and depends a lot of economy on it. So I will try to explain you briefly the multiple services that is offered by Galileo and some of its unique characteristics. Galileo, usually, sometimes we say among us that we started 20 years later than the other existing systems, but we are currently and technologically the most advanced one. In fact, Galileo has features and provides services that no one else in the world provides. And I think that is also a reason why we are so proud, and we should be proud as Europeans, of having this project made by Europe. So the Galileo has 5 different types of services. And what you see here in this slide is a very summary of it. And the different colors on the services, it means what is available now, what will be available by 2025, and what would be available in the long term. And for us, long term is 2030. So starting by the open service. The open service is basically the service that you get on your cell phone. Everyone gets this signal in their cell phone. And you need to know that today, every receiver sold in Europe, so the receiver that you have on your cell phone, the receiver that you put in your car, they are Galileo enabled. So that means that even if you are not aware, even if you cannot see it, you are using Galileo signals. So this open service is open to anyone to use. That's why its name speaks by itself, right? So it offers positioning, navigation, and timing in 3 different frequencies for free. One of the services that we are working based on this is called the Emergency Warning Service. And this will allow to, for example, in a case of a disaster or earthquake, a flood, where the ground infrastructure for telecommunications are damaged, it will allow still the authorities to communicate with you on your cell phone, for example, sending you a message saying, stay away from here or be aware of this, based on the GNSS signals that your cell phone will still be receiving. And of course, this creates, for example, the possibility of geofencing, that if you are in a certain area, you will receive that type of message. And so this will allow, it's one of the services that we are working on based on the open service and should be there by 2025. Another, by 2030, we expect to have advanced timing. So this is improved timing service, as well SSV, and SSV means space server volume. So this is actually for users in space. So there's this market opportunity also, and the area of applications that can be developed by providing GNSS services in space to other satellites, to the launchers, etc. Then we have the public regulated service. And this is a service that is highly secure, highly precise, like it said, encrypted, more robust, unlimited, uninterrupted access. And this service is limited access also. It means that we provide the service and it's up to the member states to decide who has access to it. And here we are talking, for example, of security services. We are talking about national authorities linked to national protection, civil protection, etc. We do have also a service that is actually a contribution to an international service that I'm very, very proud of it, that is called the search and rescue. So there's this international system called COSPAR-SARSAT, where you have contributing missions. So you have different entities, different systems contributing to this system. And it's used by people in distress to ask for help. So, for example, the most common example that I can give you and most straightforward is imagine that you have a sinking ship and you need to ask for help. So you ask for help, but you need to share where you are. If you fall on the water, you need to share where you are so that the rescue teams can acknowledge your distress request and they know where you are standing, where you are in the water for them to get you. So the search and rescue, what it does is, so the person falls in the water, for example, it pushes a button in what we call a beacon, a search and rescue beacon. And this signal is transmitted via the Galileo satellites to the ground infrastructures, and from the ground control stations, it goes to the national authorities responsible for this type of rescues. The advantage of Galileo in this system, and one of the advantages of Galileo in this system, is the level of precision and quickness in having this. So before, it would take up to 4 hours to the signal to be received, and the area of search would be about 10 kilometers radius. So since Galileo is up and running and contributing to this signal, this distress request time was actually reduced for a few minutes, and the area for search is narrowed down for 2 kilometers. So this actually helps a lot of saving lives. And one of the unique features that Galileo offers in this contribution is, and you can see here, forward link, acknowledge, return link, TWC, RDBA, DPS, all these type of words, because this is actually features that no one else is able to provide it today. So what happened until before Galileo appeared in this scenario was that people were pushing the button and they were waiting. They had absolutely no idea if their message, the distress message, actually arrived to the destination or not. So we included the possibility of an acknowledgement that the message was received. So the person pushes the button, and in exchange, it receives a signal. It depends on the beacon, can be a light flashing, can be a message, etc. But receives something telling you the message was received, help is on its way. Okay? So after we working on this, what we call the return link, we kept improving this, and this is what you see here, is that we start working also on the possibility of two-way communication. So, and with a return link, you get like a flash, a light, a beep on your beacon, but you don't know anything else. So what we are developing now is actually the possibility to send back and to be able to communicate between the distress teams and the people in distress. And this is on its way. Another possibility is the RBA, so that means remote beacon activation. It means imagine that you go for a hike in the mountains, you take your personal beacon, and you don't show home. You know, my husband likes to do mountain biking. I start forcing him to take a personal beacon with him because he goes to the middle of the woods. I have no idea. He has no cell network because you still have a lot of blank spots even in Belgium. So if something happens, how do I look for him? How I can send help? So the remote beacon activation, of course, under certain conditions and rules, will allow you to have this possibility that if my husband doesn't show up in time for dinner at home, then I can send a return link. I can remotely activate his beacon, and this way we know where he is, and the authorities can, of course, ask for help. Like I said, this is a possibility under certain rules to foster responsible use. Then we also have the distress position sharing. That is also another thing that we are working. And this means, for example, that imagine on the ship coming back to the sea, it means that the ship can, or the person can share their distress positioning, their position via using the GNSS signals, for example, with other vessels in the facility and close by. So this is a bit what we are in the making for search and rescue. And going back to one service that was actually announced operational beginning of this year is the high accuracy and authentication. We are talking here about a very high accurate service, about 20 centimeters accuracy, for free, provided for free. And for example, that is extremely important when we are talking about autonomous driving, for example. Okay, it also has, and we are working, and so by 2025, this will be there, is what we call the signal authentication services. This means that the signal transmitted by Galileo has a feature, a security feature that will allow you to be sure that you are receiving the signal from a Galileo satellite and not from a hacker next door, okay? And this is extremely important to guarantee the safety and security of the development of the applications that take into account the use of the signals. We have the same type of feature also for the open service. And this is something that is unique. Only Galileo signals offer this signal authentication, what we call on the open service is the navigation message authentication, and we will have the same for the high accuracy too. And of course, we are also working in the time frame of 2020 on the advanced signal authentication services, because again, this type of service, the high accuracy, it will be used or can be used for certain type of areas that require a lot of reliability, and we need to work to have these technical features to ensure also that reliability and precision and security for the users that are using this service. Not the least, we have the safety of life is also a contribution. And this is mainly for aviation adoption. So we are talking about takeoff, landing of airplanes, for example. And here it works together with EGNOS V3. So that is the third version, the third evolution of the EGNOS system. Like I mentioned, the regional systems work together with the global systems. And this is precisely the case. And EGNOS V3 should be also operational, and all these contributions should be operational also by 2025. So I gave you a bit of overview what are the different types of services that Galileo has, and I can understand that this might be a bit abstract because we don't see, we are not aware that we use it. It's not exactly like Copernicus that we can see a photo and based on that we can, our imagination can flow. So I will try now to go a bit more on the applications and how this works. You need to know that everything that is related to the development of Galileo and EGNOS, the same way as for Copernicus, we also consult our users. We have a user forum also, we call it the eGNSS user forum, that is managed by our agency in Prague, so the European Union Space Program Agency, EUSPA. And they are the ones dealing with everything that is related with what we call the downstream. So it means they use the space data and services as an enabler for different areas of application, and to take this end users that can be a company in the health sector, or it can be a energy company, etc., to take their needs, what are their problems, and then we try to see how we can, via the evolutions of Galileo, reply to these questions. And of course, ELSPA also does this matchmaking between these technical aspects of Galileo and Copernicus and the end users and the companies in the process that in the middle of the process that know how to operate and to create these applications space enabled. So how, coming back then to reality, into our daily life, making this a bit more concrete, you need to know that today there's more than 4 billion users of Galileo, and I can assure you that most of them are not even aware that they are using Galileo. Precisely because when we are talking about space-enabled applications, sometimes our end user is not exactly the person that understands or that is aware that they are using satellites, right? And every person in the world at this moment uses an average of 50 satellites a day in doing their normal life every day, and most people are not aware of this. So you can see here a few examples on where we are using already Galileo and EGNOS, since cars, because you know that the new models for cars in Europe, they need to be equipped with eCall equipment. And via the policy work, we included this feature that eCall needs to be using satellite navigation, namely Galileo and EGNOS. So at this moment, you have more than 55 car brands selling more than 150 EGNOS and Galileo enabled models. Then you also have, for example, drones, you have, like I said, vessels, so maritime, you have, for example, mapping devices and receivers for surveying. You have in that agriculture, you have 97% of the new tractors in Europe. They are using already satellite navigation to optimize agriculture. And this, of course, has a huge impact, for example, on Green Deal, you know, and the ambitions of reducing emissions, because you start being more precise, so it means you use less fuel. Or you want to spread pesticides, but because you do it in a more precise way by using satellite navigation, that also means you use less pesticide, less fuel. You also have, this also translates in savings for the farmer using it. Of course, you can see much more information about all the potential on the market on a report that is done by ELSPA every 2 years. That is, we call it the ELSPA market report. This is actually a reference report in the world, and it maps precisely all different areas where you can have innovative solutions using both satellite navigation and Earth observation services and data, and also the future trends in all these segments. It's what we called market segments. And there are actually 17 market segments. You can see it mapped here on your screen, all the different areas that we work. These are also all the market segments where ELSPA collects user needs. So there's all these different types of boxes, let's put it this way, where all the end users come together and where we also collect user needs.
Vera,
but this is
sorry to interrupt. If you can wrap up quickly so we can keep
yes,
more or less
I'm
the
almost
time.
finishing.
Sorry. Yes,
No
thank
problem. Then, so what you see here is that ELSPA is also the place where if you have an idea and you need to have assistance on developing your idea or your application, ELSPA is the place that also can help. In fact, ELSPA is the agency that is responsible for what we call the Horizon Europe downstream calls for satellite navigation. And so that means that they open regularly calls that you can apply. There's also prices, and we have also they also run the Cassini project that is actually a support to investment to development of applications using space data and services. So if you have any idea related from agriculture to road, this is the place where you can go, and they can assist you on these aspects. And I think this is my last slide. Let's just check. So a few examples of very concrete examples of satellite navigation enabled applications. Like I said, there's a huge range of it, but I just wanted to finish my presentation with very, very concrete examples of daily life. What you see here is actually 4 different types of projects that are using satellite navigation. NIM is actually a ring, as you can see in the photo. And it's a distress ring. So it means that, for example, victims of violence, imagine victims of domestic violence, they can use this ring to call for help. So it's possible to program to whom you want your distress request to be signaled. And if the person pushes a button in the ring, automatically the distress request is sent with the location, so that help can come. Connected Robotics is a project of drones. It's actually a Portuguese project that I met a few years ago, and I was very impressed because it has a double use. So in a way, it can help, for example, with the delivery of urgent medication in urban setting, because it doesn't get stuck in the traffic, for example. So it can do the deliveries automatically. But at the same time, and with the photo that you see here, is actually in remote areas. It's used by social services to provide hot meals to isolated people, like elderly people, for example. So what you actually see there is the transport of the meals. Freewheel was a winner of one of the competitions that IOSPOR organized. And actually, it has also a double use. In one way, it with a receiver attached to a wheelchair, it helps to map the accessible paths in the cities, and this information is shared among the other users of the platform. So this is a crowdsourced platform, and at the same time, that information is also used by public authorities to do urban planning, to make accessible urban planning cities accessible for everyone. Not but not the least, the Blind Explorer is just one type of applications that is used for give autonomy to people with visual impairments. So this allows them to circulate in an autonomous way through the city without assistance, just by using the application and by listening the indications that it has. Like I said, this is just very few examples of all the potential that you can have from the use of satellite navigation services. And of course, if you have any additional question, I remain at your disposal. Thank you so much.
Thank you. So anyone, if you have any questions? Okay, there is the first one coming in. So the question goes, I have seen Galileo satellites only in combination with other systems as part of the multi-constellation. But does Galileo work also autonomously, and how precise it is then? And you can.
Okay,
yeah.
Indeed, and that has a very particular reason. As if you see the market report of ELSPA, you will see that the majority of the receivers, especially the receivers used in the mass market, as we call it, they are what we call multi-constellation receivers. So that means that the receiver itself is able to calculate your positioning and navigation and your timing using signals from 2 different constellations. And this is actually a good thing, because imagine, that you have 28 satellites of Galileo in orbit these days. You have around the same operational from GPS. So then what happens is that if you are in an urban canyon, so it means if you are in the middle of a street with high buildings, you will not be able to have in view the same number, the minimum number of satellites that you need to calculate your position. So it means that you need minimum 3 satellites and a 4 for reliability satellites in view, in your horizontal view, to have your positioning. What happens is that in urban canyons, so it means where you have like big buildings around, the signals might be blocked. So you will not have these 4 satellites in view. So by using multi-constellation receivers, like I said, it's the majority of them in the open mass market, it guarantees that you will always have at least the minimum number of satellites to have an accurate position. Then the second part was asking about if it works autonomously. Yes, it does, of course. If you only have 4 satellites of Galileo, you will still have your positioning. You will still be able to navigate only by using it. You do have receivers that only use Galileo satellites. Usually more in the professional segments, you'll have receivers that are only using Galileo, or that you can choose which constellation you want to use. I put in my slides one website that is www.usegalileo.eu, and there, for example, you can see in all different type of market segments, professional and mass market, what are the equipments that are Galileo enabled. The precision of Galileo, all the precision of Galileo is calculated and based on Galileo itself. And we can assure you that is much more precise, is the most precise system at this moment existing. We also publish every 3 months what we call the Galileo quarterly report produced by the reference center. So we are the only system providing this and being total transparent, where every 3 months you can see what was the performance of the Galileo services, if there was a problem and why, what happened. And this information is publicly available, also via the site of ELSPA, because they are the ones responsible for managing this center. You can also have that access to that information, and you can see per services exactly what is the performance of the services. I hope I managed to reply to your question.
Thanks a lot. I think so. Thanks a lot for the presentation and for the questions. And I have a thank you from the person who asked the question. So I think it's covered. Thanks a lot. I don't know if you can stay a bit later or not, but we will share the presentation and the recording with the NCPs only. Now, for the sake of time, I think we need to move on. So towards the use cases. So we have 3 use cases. We're running a bit over time. I hope it's okay for everyone. The first one is from Kersti Kangro from the Remote Sensing Observatory of Tartu University in Estonia. And without further delay, Kersti, you can share your slides. And for the attendees, let's take questions at the end of all of the use cases. So not after each, like for the first 2 presentations. Thank you.
Hello from my side. Can you see my slides?
Can somebody confirm? Yes, seems it's okay.
Yes,
good.
See the slides.
Okay, then I'll start. I will show 3 cases from my working group. This means that I am not the only one who has done it, but it's combined effort. And I'm showing how we are using Copernicus data for monitoring water bodies. Mainly it's done for the sake of optical water quality parameters. And waters are optically different, as you might know. They range from really clear waters, really transparent blue waters, up to nearly black waters, which means that they need adapted approaches to retrieve water quality parameters correctly. And here's one example where we can see that the ranges from quite transparent water to nearly untransparent water due to mineral sediments and unorganic matter and color dissolved organic matter coming from the river, which means that standard products do not always work as we would like them to be. And there exist many processing methods and various algorithms which are good in some places, but not really that good in other places, which means that we need to test them for our own specific location. And atmospheric correction is always a major challenge. There's an example of different atmospheric correction products to retrieve chlorophyll A concentration combined with in situ measurements. And we can see that not all corrections are performing equally good, but there is at least one that we can use that we can take and move forward. And we also definitely need field data to validate and tune the algorithms. So we just can't without it. Example one, which I'm going to give, is about downstream application development for supporting the implementation of European Water Framework Directive in Estonia. We have taken selected lakes, and this is a website which is publicly available. And the satellite images from Sentinel-2 and Sentinel-3 are combined with point measurements. There is possibility to use specific buffer in those bigger water bodies to reduce adjacency effect. And we can look at RGB images, and we can look at thematic maps of chlorophyll A and transparency, and also get information about time series. And the cover period for satellite images is from 2015 up to now. So we can look at the specific point from where remote sensing data can be retrieved, and there is also in situ data present. This lake, Võrtsjärvi, is really well covered with in situ data, since there's a monthly monitoring which is taking place, which means that we get 1 point per lake per month. But as we can see, the remote sensing possibilities allow us to retrieve much frequent time series and combine with in situ sparse measurements and to retrieve information about various years. Here we can also have mean for the vegetation period and the yearly mean. And the color coding in the side and in one side and in the other side represent the Water Framework Directive classes according to chlorophyll A. So we can say that Copernicus data support sparse in situ measurements, and as I said, in this case, they're even quite dense. We can say something based on Copernicus data about the other lakes where we don't have that much of in situ measurements. For example, here in Lake Pihkva, we have only a couple of points which were measured in August once per year, but now we don't get any information about that lake. But we have Copernicus measurements, and according to them, we can see what is happening in that lake area and how high are the chlorophyll values which can be retrieved. We can get information about more dense information about seasonal dynamics. In ideal, we can get the Sentinel-3 image once per day, but as you all know, the sun is not shining every day, at least not in Estonia. And this means that we still have information over several days or once per week, although we might have it daily, since we have quite good satellite coverage. And we can say something about spatio-temporal variability, which means that we can take 1 point and get information about that, but we can also take the lake area and get the average information about that, and we can combine it with RGB image, which shows that we have bloom in Lake Peipsi-Suurjärv, and we can also see that the satellite chlorophyll A is quite high. And according to that, we can get bloom information, we can get the bloom intensity, we can get bloom duration, and we can extend it over the period of sentinels and over the period of envisaged meris, which gives us longer data starting from 2002, and combine them with different other variables to get more knowledge about the lake and what's happening there. And we can get information from Sentinel-2 over small lakes. This is one quite eutrophic lake, Lake Veisjärv, and we can see that only really rarely in situ data is gathered from there, but it fits relatively good together when we look at satellite data and in situ chlorophyll A data. And we can say that this lake is generally not in really good status. And we can download the data, and you can also get information under the tab Info, which explains how the chlorophyll A and transparency are retrieved, because different algorithms are used when we take into account Sentinel-3 and Sentinel-2. Then another example, which shows synergy between optical and altimetry data. We have developed a methodology for correcting phytoplankton and transparency estimates, and also related ecological status according to the water level in lakes. This can be done for large lakes, but here's an example of Lake Võrtsjärv, where the water level can really vary. It can vary more than 2 meters, which also has an effect into the chlorophyll A concentration. But since it's a natural variability, then we need to somehow correct it to get right ecological status classes, that we don't get too bad estimations. And here we can see the long term. These are those small black lines, which are the same in every image. These are long-term monthly average water level values. And then there's measured water level values, which are the big black dots. And then there are retrieved water level values in those days where also chlorophyll A is measured. And then we can take those measurements, and with correction method, we can change the chlorophyll A values according to water level. We get the corrected values afterwards, and we can estimate the ecological status classes. Here is 2 examples, one from the year 2016, where the water level was higher than usual, and then about 2019, when the water level was lower than average. And we can also say that in 2019, the amount of data points retrieved is much higher due to combination of Sentinel-3A and B. And then the third example, where we can say that we have developed bloom indicators for coastal area and open waters. We have used Case2 RCC processor, and we got chlorophyll A values for all cloud-free days for all our 16 different coastal areas, and the calculated spring bloom index, which showed that there are some coastal areas which have really high values of spring bloom intensity, and also we have combination of those areas where we have really low spring bloom intensity, and bloom starts from 5 micrograms per liter. So we might say,
sorry to interrupt, but if you can wrap up quickly, so we can keep the time. Thank you.
This is wrapping up slide. And I can say that Copernicus allows long-term capability to support environmental monitoring data. And we can see that this that even from RGB images, we can saw the differences from 10 days time scale of lakes under ice to lakes which are really not under ice, and the algae are actively growing there. And so thanks for listening.
Thanks a lot, Kirsty, and sorry for having to hurry up. Just trying to keep the time to more or less so that we don't go too much over time. And with that, I would like to give the floor to Siim. And if Kirsty, you can stop sharing the slides. And to my understanding, Siim, you don't have slides. You are still muted.
No, I don't have, sorry.
No worries.
That's because the system, the interesting system we are developing is not ready yet. So I don't have anything to show. But yeah, my name is Siim Randver, and I am representing here an Estonian paying agency called Agricultural Registers and Information Board. The main purpose of this institution I work is to provide European subsidies to farmers and manage agricultural registers. In order to get subsidies, the farmers have to obey some rules or meet certain requirements. And that is how the common agricultural and environmental goals are supposed to be achieved. So my work is to check if the farmers do meet all those requirements for receiving support. And I work in a control unit and deal with collecting data from the field on the spot, and also measure the agricultural parcel sizes with GNSS devices and or using orthophotos. And until this year, on the spot checks were the main method of controlling. So every year, some 5% of the applicants had to be checked on the spot. And if any violations of the support requirements were found and some differences from the data provided in the application were discovered, the subsidy was reduced. And in the case of major violations, the reductions could be quite large. But starting from this year, the principles of control will change to a very significant extent. Now all the agricultural parcels, it's almost 1 million of agricultural parcels, and all applicants will be monitored automatically by an information system that analyzes and compares a large number of satellite images throughout the whole summer. It's from May to October. And this information system is called Area Monitoring System, and it will use data from Sentinel-1 and 2. Yeah, as I mentioned already, the system is not ready yet, but it has to be ready soon, before the control period starts. It's almost in the beginning of the summer. And simply explained, the area monitoring system is a very complex information system that compares Sentinel images throughout the summer and tries to detect changes on the fields, and finally compares all the detected changes with farmers' application data. So the area monitoring system must be capable to detect uneligible objects. These are the roads, buildings, bushes, and a large group of trees on the fields. On those areas, farmers is not to they can't get money for those areas, and the system must detect whether the entire field is covered with the same crop or has the same land use, or whether the same agricultural activity has been carried out. For example, is the field uniformly mowed or uniformly plowed? And it has to detect plowing and detect the fields without vegetation. And also it has to detect mowing and grazing. So the system monitors the biomass reduction. And the system determines whether the crop growing in the field still corresponds to what was noted in the application. And eventually, if the system gives the signal that an anomaly has been detected in the field or requirement to receive support was not being met, we will send an email to the applicant asking them to clarify the situation. And then the applicant may prove that he or she is right and send a photo about that, what proves that. And a special photo application, mobile application, is developed for this reason by our institution. And the farmer has also the option to change the application, change the crop or reduce the area of the fields or completely remove the problematic parcel from the application. And if the applicant does not respond to the letter or explanation is insufficient, the field will be sent to an on-the-spot control. And this is all about the use of Sentinel data. But I said that we use the Galileo satellites as well, but there's not much to talk about because we just, if we have to measure some parcels, then we use GNSS devices, and the GNSS devices use Galileo satellites as well. And thanks for the attention. Yeah.
Thanks a lot. Thanks a lot for your speech on what you do. That was very interesting. And we leave the questions to the end. So I would like to ask Liis Sipelgas, if you can share your slides. You are our last speaker. And if you can keep it to maximum 10 minutes, that would be great.
Yes, I can keep it to 10 minutes.
Thank you.
Can you see the slides? It's okay.
Can someone confirm again?
Yeah,
I have
it
the same
works.
issue.
Yeah, it is
Yes.
okay, and it is well, the right
Okay.
presentation mode, so that's perfect.
So I will introduce you as in first presentation, Michael introduced you services at European scale. I will introduce you a couple of services that we have taken down to the regional scale by using different Sentinel data. And so services are running operationally at the Estonian Environment Agency. And so services are ice charting service and hydrological monitoring service. But let's start with this ice charting service. First of all, I say a few words about the background. The responsibility of the Estonian Environment Agency is to provide daily ice map about ice-covered areas and also about ice thickness and ice types. And those maps have been produced since 1940s. And of course, over the years, different sources of information for ice mapping has been used. Earlier, those were mainly observations, but of course, lately, those have been mainly satellite data. A few years ago, there was a decision in Environment Agency to upgrade all of this production by starting use new satellite data, new Sentinel data, and also develop new software for map production. So under that project, several developments were made. First of all, there was a need to develop new satellite processing for Sentinels. Then there was, of course, need to develop a GIS tool for the ice expert where the chart can be finalized. and there was a need to develop a web map from where the ice chart is published to the wider public. So what was done and what is now working operationally, every day as a new product of Sentinel arrives at the Estonian National Satellite Archive West Hub, the process starts, the visualizations, first from Sentinel-1 data is produced, and then the visualizations from Sentinel-2, different color composites are produced automatically, and then also the color composite from Sentinel-3. So all of these, and also we use Sentinel-1 also, we produce predefined ice types from using the machine learning algorithm. So you can get a product already with the classified ice. And all of this information will then be transferred to the GIS ice charting tool, where we have special functionalities where the ice expert can finalize the chart. The ice expert can move automatically the polygons to the ice chart, the predefined polygons. And after the chart is finalized, it will be then transferred to the GeoServer, and from there to the open web map. The web map is open and free to everybody. What you can view there is the final latest ice chart and also ice chart from previous days. You can view there also the temperature idle lines. These are all from Copernicus data derived from the Siemens data products. And then you can also view there information that has been sent by volunteers through the mobile app. Of course, you can view the Sentinel data set visualizations. This is Sentinel-3 visualization, and you can view the Sentinel-2 visualization, and also you can view the Sentinel-1 visualization. This regional service has been available now for 2 winters, and it has become quite popular. It has a lot of accesses. People are using it for different information. It's used for touristic purposes. It's used by the ports. And there are also plans to continue with different developments. And I would say just to note that it's very important in regional scale to have a regional service, because people are used to go to look some information in certain places. And for example, for ice information, they want to go to the Estonian Weather Service, where they have used to go to find some information. So the other service that is now something under development in Estonian Environment Agency is hydrology service. And Estonian Environment Agency is also responsible for the National Hydrology Monitoring Network, meaning the water level stations, where the water level and flow rate are measured daily. And in 2020, the project were initiated. The hydrology department wanted also include or uptake the Sentinel data into the monitoring system. So we tried to made a concept how we integrate it. And of course, first we wanted to have like operational water extent information from Sentinel-1 and Sentinel-2. And secondly, there was a need, so-called like to build up an environment where hydrologists can call out statistical calculations for water frequency for selected time and space. So this is also now working operationally. Every day as new image arrives, again at HESTA, the water mapping starts, and the output is vector format file with a water extent. And also the hydrologist can start or call out the statistical calculations environment. First, you have, of course, defined the time and space, and then automatically it calculates or maps the water extents on all images, what it can find for this period. And it also creates one single image with the water frequency in selected area. And now I just show some example what you can do with this. You can find some lake. Then you can look at how frequent was water in over the 5 years. And then you can also compare it to the latest overflight where the water is mapped. And you can also then view the interannual changes. Here you can 17, 18, and you can see and what was the water extent in different years. In addition to the latest water status. And this is some example also from the other areas. Here next to the lake, this is a wetland area, and you can see the interannual changes in the for different years, and also then the water extent in the lakes. So this is also one example. So actually that's from my slides, but I wanted to say a few words about the regional scale services. Those Copernicus services are very nice, but in regional scale, you also need a regional scale services because often they have different like expectations, what you want to see or how you want to see your service. So in different projects, they are very nice way to develop such kind of services also at the regional scale. So thank you. It's all from my side.
Thanks a lot, and thanks also for keeping time. Very well. So we have a few minutes if you had questions for our 3 use cases. Thanks, by the way, for all of you being here and giving examples, which is very important. I don't know if I think some people also had to leave, but if you had any questions, please shoot. You can write them in the chat. I don't see anything coming in. Maybe it's because we are slightly over time. Okay, yes, please go ahead. So, Michel.
Yeah, thank you. I just wanted to compliment and react to what Liz just said about the kind of regional dimension, which is quite important. In fact, what we try to do in Copernicus is to find the kind of common denominator between all the user requirements at European level and the denominator also that matches most of the needs at national level, right, across the different member states. Of course, we cannot tailor all our products for every specific needs at regional or local level, but yet we are trying to find the right way to address that, still using this kind of common denominator approach. And one of such mechanisms that we are starting implementing within Copernicus are those national collaboration programs. They are starting to emerge and being tested now, at least within the Copernicus Atmospheric Monitoring Service, the Climate Change Service, and also in the Copernicus Marine Environment Monitoring Service. The approach that we are trying to take here is to have a kind of template with you know, some offers, product offers or application offers that we offer to various member states, and they can just pick across this wish list the ones that they would like us to tailor some products or applications for. This is a way for us to use this common denominator approach, yet having a mechanism to tailor some of our products using this template approach and really address the specific needs of the a regional or member state service. And I would assume that this will emerge in the other services as well. But the ones that I'm aware of are those 3 services for the time being.
Thanks a lot. That was a very good comment on what Elise was saying. I don't see any other comments or questions coming in. So I take it that we can close the webinar. So to remind you, we will share the slides and the recording to NCPs. And I would like to thank all the speakers. This was very interesting and useful for us. And thanks for taking the time. And I wish you all a very lovely day.
Thank you.
Thank you.
Thank you.
Most welcome. Bye-bye, everyone.
Thank you. Bye.
Bye.
Bye. Thank you very much. And I would like to thank especially those who had to join in at the very last moment and who saved our day. So thanks a lot.